Good morning, and welcome to the Collaborative on Health and the Environment Alaska teleconference on toxic chemicals that disrupt hormones, impacts on fish and people. My name is Diana DeFazio, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. CHE Alaska is a regional partnership group of the National Collaborative on Health and the Environment, and CHE Alaska aims to advance knowledge and effective action to address growing concerns about the links between human health and environmental factors. You can find more information on the websites www.healthandenvironment.org, that's the National Collaborative on Health and the Environment website, and www.akaction.org, which is the website for Alaska Community Action on Toxics. Before we get started, I want to clarify that this is an audio-only teleconference and not a webinar. However, you can go online and download a PDF of Dr. Solomon's presentation to follow along. If you RSVP'd for the call, I sent you a link to the presentation yesterday. If you don't have access to that link now and need it again, please email me at diana@akaction.org, and I'll be happy to send it to you after I introduce our speaker. The call will last 1 hour, and except for the speakers, all participants are muted during the presentation. So now, I'm so pleased to introduce our guest speaker, Dr. Francis Solomon. Dr. Solomon is an environmental biologist with 25 years of experience in environmental agencies, focusing on the biological impacts of toxic water pollutants, pollution prevention and control, and cleanup of contaminated sites. She holds a master's degree in environmental health and PhD in fisheries from the University of Washington, Seattle. Dr. Solomon is passionate about bringing her work experience and knowledge to the classroom. She teaches short courses and gives lectures for environmental professionals, healthcare professionals, and the general public in Washington State, Alaska, and Canada about impacts of metals and persistent organic pollutants, including endocrine disruptor chemicals, on aquatic ecosystems and human health. In fall 2010, she lectured about EDCs to faculty and students at Hokkaido University and Keio University in Japan. She teaches environmental pollution courses at Western Washington University and the Evergreen State College, Tacoma, and has also taught at the University of Washington, Tacoma, University of British Columbia, and Northwest University in Xi'an, China. Dr. Solomon is an avid volunteer, giving generously of her time to projects for the Washington Toxics Coalition. She is president of the Pacific Northwest chapter of the Society of Environmental Toxicology and Chemistry, and serves on the board of directors of the Coastal Watershed Institute and the Seattle chapter of the Association for Women's Science. And Fran, just before you begin, I want to repeat the fact that this is not a webinar. It was listed that way on some of the promotions. It is an audio-only teleconference, but you should all have a link to the PDF of Dr. Solomon's presentation so you can follow along. So Fran, would you like to begin?
I'll be glad to. Well, Diana, thank you for the introduction and for the opportunity to present a teleconference through Alaska Community Action on Toxics. And thanks also to everyone in the audience today for your interest in the topic of toxic chemicals that disrupt hormones. These are called endocrine disruptor chemicals. To save time during my presentation, I will use the abbreviation EDCs. And I will let you know when I'm moving on to the next slide, which I'm doing right now, slide 2. So I'll begin my presentation by talking about how EDCs act, the properties that make them toxic, and how they get into our water bodies and air. I'll explain how fish and humans are exposed to these chemicals and why young life stages are the most vulnerable to these chemicals. Then I'm going to zoom in on the impacts of 2 specific groups of EDCs. I'll finish my presentation with a discussion of 2 new bills that have been introduced into U.S. Congress, why we need to support them, and also suggestions of individual actions we can take to reduce our exposure to EDCs. And I'll take questions after my presentation. So slide 3, first I want to define toxic chemicals. A toxic chemical is a chemical that can harm the survival or health of an organism. So that is a person, another animal, or a plant. Some toxic chemicals occur naturally, but many have been manufactured by us for use in our everyday lives. And these chemicals have made our lives better and easier and more convenient. But we've been discovering in recent years that many of these chemicals have their downside. So among toxic chemicals are organic chemicals, chemicals that contain carbon. There are over 200,000 human-made organic chemicals, and these include the EDCs, which are recent chemicals of concern. Slide 4 presents the official National Research Council definition of endocrine disruptor chemical. Any chemical with the potential to alter hormonally mediated signals in plants or animals. So that means essentially it's a chemical that disrupts the function of endocrine glands. Endocrine glands produce hormones. Hormones are chemical messengers that travel in the bloodstream to a target organ where they then produce some behavioral, physiological, or anatomical response. The examples of some endocrine glands and hormones that they produce are the thyroid gland, which produces thyroxine, the pancreas, which produces insulin, the ovaries, which produce estrogen, and the testes, which produce testosterone. Next slide is a schematic showing how EDCs act. So in the left part of the slide, you see the normal situation. A hormone normally binds to a receptor that's on the surface of or in the interior of a cell. It's like a key and lock arrangement where the hormone is like the key that is unlocking the receptor. And when the hormone binds to the cell receptor, some response is induced, is brought about. On the right side of the slide, you see what happens when an endocrine disruptor chemical is present. The EDC will bind with the cell receptor, thereby blocking the hormone from doing so. So the way in which the cell is supposed to respond does not happen. Some EDCs can mimic hormones. They can trick the cells into thinking that they are the hormone. For example, if an EDC is able to mimic estrogen, when it binds with the cell receptor, the cell will then respond to the EDC as if it were estrogen. So the cell will respond in the same way as it would respond to natural estrogen. So these effects where a hormone is mimicked or hormone binding is blocked bring about some very fascinating and alarming consequences. Next slide. This slide lists some examples of EDCs. It's very common. I had friends who remember growing up seeing airplanes spraying DDT, the pesticide DDT, on agricultural fields, and they would run behind the plane, not realizing the possible effects of their exposure to the DDT. In addition to DDT, other pesticides have been found to be endocrine disruptor chemicals. So are the flame retardants, the PBDEs. And I know that there was a recent teleconference on the impacts of flame retardants. Other EDCs are bisphenol A, about which there was also a recent teleconference. Today I'll be focusing on the phthalates and the perfluorinated compounds, or PFCs. And these are also sometimes referred to as the Teflon chemicals. So you can see from this slide, EDCs are found in everyday products in our home. Several properties of EDCs contribute to their toxicity. We're now on slide number 7. First, EDCs dissolve well in fats. The technical term is lipophilic, which literally means fat-loving. So since our cell membranes are comprised partially of fats, EDCs can easily cross cell membranes and then be taken up by the organism. EDCs will in particular be taken up by and accumulate in the fatty tissues of the exposed organism. This property is referred to as bioconcentration or bioaccumulation. This means that the level or concentration of an EDC in an exposed organism in a plant or animal or person will be higher than the level of the EDC in water or air or soil or sediments. The term sediment refers to essentially the soil at the bottom of a lake or river or stream or bay. So it can be made of sand or silt or gravel. Another property of EDCs that makes them toxic is that most of them are very persistent. This means they do not break down easily and they remain for a long time in the body of the exposed organism. In other words, they have a long biological half-life. Slide 8, next slide, illustrates the concept of half-life. This refers to the amount of time that it would take for half of the EDC that an organism has been exposed to leave the body of that organism. This graph was prepared by my colleague, Dr. Steve Gilbert, a toxicologist in Seattle. And the horizontal axis indicates the time in hours for a hypothetical EDC to be present, say, in the body of an exposed person. The vertical axis indicates the concentration of the EDC. So if you look at that graph, those of you who have the slides in front of you, you can see that at the outset, the concentration of the EDC in this particular case was 10 micrograms per milliliter. And after 4 hours, only 5 micrograms per milliliter were present in the exposed organism. So this means that in this case, the half-life of this hypothetical toxic chemical was or is 4 hours. However, in the case of EDCs, the half-lives are usually months or even years. So once an organism is exposed to an endocrine disruptor chemical, that EDC stays in the body of that organism for a very long time. The EDC is persistent. Next slide. Slide 9 illustrates another property of EDCs that causes problems for exposed organisms. That is biomagnification. Biomagnification refers to the fact that as you go up the food chain, the concentration or level of an endocrine disruptor chemical will be higher in each predator than it was in the prey, than it was in what the predator just ate. This is a picture of a simplified Arctic ecosystem. Each little green square represents a given concentration of an endocrine disruptor chemical. So if you look at the bottom left-hand corner of this picture, you see insects. And there's only one green square indicated. So this shows that the concentration of the EDC was relatively low in the insects. But if you follow the orange arrows and you go to the shellfish, you see that there are 2 squares within the circle there, indicating that the concentration of the EDC will be higher in the body of the shellfish than it was in the insects. Then go across to the right, you see that finfish have eaten the shellfish. Concentration of the EDC is higher in their bodies. Seals and other marine mammals eat the finfish. The concentration of the EDC is now very high in the marine mammals. The top predator in this particular food chain is the polar bear, and you see that the polar bear has many green squares indicated, showing that the concentration of the EDC will be very high in the polar bear and much higher, much higher than it was in the insects, which are towards the bottom of the food chain. Well, we humans are also top predators in food chains, so we're in the same position as the polar bear, and particularly in Arctic regions where fish and marine mammals, including the blubber of the mammals, are large parts of the diet, people will be exposed to and will accumulate very high levels or can accumulate very high levels of EDCs in their bodies, much higher than the levels of EDCs in the food that people are eating. Next slide, slide 10. So there are several ways in which EDCs can get into water. First is through sewage. Although sewage is treated before it's discharged in most places, the current technology does not remove EDCs from the sewage. So consequently, legal discharges of treated sewage, treated wastewater plant effluent, will contain EDCs. Same is true for industrial waste discharged legally from industries. Stormwater is another way in which EDCs can be transported into water bodies. When it rains on a hard surface, such as a sidewalk or parking lot or road, the rainwater will pick up whatever pollutants are present on the hard surface and will transport those pollutants into a catch basin and then through stormwater pipes and out to the nearest natural body of water, the nearest lake, river, or bay. Stormwater is not treated. It does not go to a sewage treatment plant. The pollutants that are picked up by stormwater are the same pollutants that end up out in a natural water body. Oil spills are another source of EDCs to water bodies. Crude oil, petroleum, contains many compounds that are endocrine disruptors. So oil spills such as the Deepwater Horizon that occurred last year and the Exxon Valdez spill in Prince William Sound in Alaska contributed numerous EDC waters and are continuing. So marine life in those waters continue to be exposed to EDCs. Household products that get into air, sewage, and stormwater will end up in water bodies. And some EDCs can off-gas from the products in which they're found, move into air, attach to dust particles, and be transported long distances. It's an important point that I would like all of you to take away from this presentation is that the impacts of a given EDC on fish and on human health are the same regardless of the source of the EDC. Next slide, slide 11. Another property of EDCs is that they can travel long distances in air, and thereby contaminating air, water, soil, and sediments far from their original sources. The wind patterns on our planet are such that wind concentrates air pollutants in the Arctic regions of the Earth. The pollutants then fall out and can fall out into snow and ice and then make their way up the food chain. So this happens to EDCs, and as I just mentioned, they undergo biomagnification up the food chain. So consequently, people living in Arctic regions are especially vulnerable to being exposed to high levels of EDCs. The Yupik women of the Yukon-Kuskokwim Delta region of Alaska have the highest known concentrations of the flame retardants of any human population in the Arctic. In this slide, the island in red is Baffin Island. It's a remote island far from any industrial sources of EDCs, yet the Inuit, the people who live on Baffin Island, have the highest worldwide levels of some EDCs as a result of this concentration in the Arctic, biomagnification up the food chain, and fish and marine mammals being a large part of the diet of the Inuit. Next slide. In order for an EDC to be toxic to an organism, the EDC must first enter the body of the organism and interact with the surface or interior of the cells. So there are several ways in which fish are exposed to EDCs once EDCs enter a water body. One way is through the gills. The gills of the fish are their respiratory organs. Their function is to extract oxygen from water and get rid of carbon dioxide, and also to extract salts from water. Because gills are very good at filtering, if they're good at filtering out oxygen and salts from water, they also will filter out any pollutants present in the water body. So if EDCs are present, they will cross the gills of the fish, enter the bloodstream, and be available for transport to all the organs and tissues of the fish. EDCs can also cross the skin of the fish and get into the bloodstream in that way. Fish are also exposed to EDCs through drinking contaminated water and through the food chain. Fish and shellfish that live in the sediments at the bottom of water bodies are also in continual contact with EDCs that accumulate in those sediments. The bottom photo in this slide is a photo of the gills of a tuna fish. The next slide, slide 13, indicates the various pathways by which humans are exposed to EDCs. EDCs can be found in air in the form of small particles that can be inhaled deep into our lungs. Our lungs are analogous to fish gills. When we use cosmetics or other personal care products containing EDCs, the EDCs can then enter our bodies through our skin. And like fish, we're exposed to EDCs through drinking contaminated water, and we're exposed through the food chain. In humans and in other mammals, there's another pathway for exposure to EDCs. Unfortunately, these chemicals cross the placenta during pregnancy, thereby entering the body of the developing fetus and exposing the fetus 24/7 for 9 months. Next slide. So another very important point that I'd like all of you to take away from this teleconference is that human children, babies, and fetuses, and juvenile fish and fish larvae are more vulnerable to the effects of EDCs than are the adults. And there are several reasons for this greater vulnerability of the young. First, a given concentration of an EDC will be a larger percentage of the weight or volume, body weight or volume, of a child or baby than of an adult. For example, if a 70-kilogram adult is exposed to 70 milligrams of an EDC, the dose will be 1 milligram per kilogram. But if a 10-kilogram child is exposed to 70 milligrams of that same EDC, the effective dose will be 7 milligrams per kilogram. So the child weighs 1/7 as much as the adult, and the child's exposure will in effect be 7 times higher. Another factor contributing to the greater vulnerability of the young to EDCs is that children and young fish and all young organisms have higher breathing and metabolic rates of conversion of food to energy than do the adults. So this leads to faster and greater uptake of EDCs. Third, adult humans and adult fish have detoxification mechanisms in place that can at least partially detoxify EDCs and other toxic chemicals, but the young life stages have not fully developed these detoxification systems. So for all of these reasons, what I say about impacts of EDCs applies especially more seriously to young organisms. So you now have an overview about EDCs, and I want to zoom in on the impacts of phthalates and PFCs. The phthalates are a large group of industrial chemicals with many beneficial uses for humans. They are a constituent of the fragrance in personal care products. They're used to harden nail polish, and they're used to soften plastic. However, unfortunately, they are not chemically bound to plastics, so they can leach out and are dispersed via food, air, water, soil, and sediments. Consequently, fish, other aquatic organisms, and people are continuously exposed to low levels of these chemicals, and we're usually exposed to not just one phthalate, but to a mixture of them. And there is a loophole in the current power of the Food and Drug Administration. The FDA at present does not require cosmetics manufacturers to list the ingredients in fragrance. So the label will just say fragrance. If the label of a personal care product that you're using says fragrance, chances are very high that it contains phthalates. Children are especially exposed to phthalates because many children's toys, such as bath toys, are made of soft plastic and can contain up to 47% by weight of phthalates. Women of childbearing age are also especially exposed to phthalates because of the high use of personal care products. The next slide just lists several examples of phthalates. There are many more, but dibutyl phthalate is the one that is used in nail polish, and DEP and DEHP are found in the fragrance in many personal care products. DEHP is also a constituent of vinyl, so therefore is found in vinyl shower curtains and vinyl flooring. Next slide, slide 17. I want to tell you a quick story about a study in which I participated with Washington Toxics Coalition and People for Puget Sound. And these are two wonderful environmental nonprofit organizations in Seattle. We wanted to find out, we know that phthalates are present in Puget Sound, and Puget Sound refers to our inland marine waters. It's an estuary. We know that phthalates get discharged via sewage and stormwater. We wanted to find out how phthalates from our home will end up in Puget Sound. The photo in this slide is of Commencement Bay, an urban bay in Tacoma. It's a pretty photo. You can't see the phthalates that are present in the sediments and the organisms in the bottom of the bay. Next slide. So our hypothesis was that phthalates in personal care products off-gas to the air, attached to dust, hitchhike on dust, end up on our clothes, and then when we do the laundry, the phthalates get washed down the drain. They go in laundry water to sewage treatment plants. The phthalates are not removed, and so these phthalates are discharged in the effluent to Puget Sound. So to test this hypothesis, we did a small pilot study in which we recruited volunteers from 6 households throughout the Puget Sound region and went to their homes, vacuumed their floors, and did their laundry. So you can imagine it was not difficult to find volunteers who were willing to let us do that. So we collected laundry water samples and then the dust samples from the vacuum cleaner and sent those off to a lab to be analyzed for phthalates. And the results showed that every single dust sample and every single laundry water sample contained several phthalates. And there was a strong positive correlation between the levels of the phthalate DEHP found in the dust samples and in the laundry water samples in each home. Knowing the total phthalate load from sewage treatment plants to Puget Sound and the levels of phthalates that we found, we were able to estimate that about 1/6 of the total phthalate load is coming from our clothing. So although this is a small study, it did support our hypothesis that this is one of the pathways by which phthalates end up in Puget Sound. And I want to add that we were careful to use laundry detergent that does not contain phthalates. as we wanted to make sure that the phthalates that we found were coming from the clothes and not from the detergent. So phthalates enter Puget Sound. They settle in the sediments. Slide number 19 shows a photo of mussels and some impacts of phthalates on organisms living in the sediments. So levels of phthalates in the sediments of the Theophos waterway, which is part of Commencement Bay and Tacoma, are often above the Washington Department of Ecology standards, which are set to protect aquatic organisms. So not surprisingly, there have been negative impacts on the organisms living in the sediments. Specifically, the mussels and the sand fleas have shown impaired reproduction. Larval development has been disrupted, meaning that fewer animals hatch from the eggs, and emergence from the eggs is delayed. So the result has been fewer live offspring and smaller populations. So you might be saying to yourself, well, I don't particularly like to eat mussels, and I don't particularly care about what happens to sand fleas. But you should, because these animals are a part of the ecosystem, and when populations of sand fleas and mussels are impacted, this means less food is available at higher levels in the food chain. For example, less food would be available for salmon. And so when these animals are affected, there's a ripple effect throughout the entire ecosystem. Next slide. Fathead minnow are a cold water, freshwater fish. When the larvae of these fish were exposed to the phthalate DBP at environmentally realistic levels, at levels that are found in natural water bodies, the survival of the larvae decreased. There was a higher mortality rate than in normal situation. Likewise, when rainbow trout were exposed to the same phthalate compound at environmentally realistic concentrations, the growth of the trout was reduced. And we now have a body of evidence indicating that phthalates harm reproductive health in humans. Phthalates mimic estrogen and block testosterone. So consequently, when human male fetuses are exposed to phthalates, and they are exposed to phthalates because their moms are exposed to phthalates, there are consequences for development of the reproductive system. So boys, baby boys, when they're born, can be born with stunted penises, anatomically abnormal penises, and undescended testicles. Dr. Catherine Main did a study in which she looked at the levels of phthalates in breast milk of new moms and testosterone production in their 3-month-old sons, and there was an inverse correlation. So the higher the levels of phthalates in the breast milk of the moms, the lower was the testosterone production in the boys. So by blocking testosterone, phthalates cause damage prenatally, and they continue to cause damage once the baby, even after the baby is born. Next slide. And this damage, reproductive health damage, continues through the life cycle. In adult males, a correlation has been found between levels of phthalate metabolites, those are breakdown products of phthalates, in the urine of these men, and reduced sperm quality. So the higher the levels of phthalate metabolites in adult men, the lower the number of normal sperm. So phthalates may be contributing to decreased fertility in men in the U.S. and other developed countries of the world. In newborn infants that were born with low birth weight tend to have higher levels of the phthalate DEHP in their blood. So although correlation doesn't prove causation, there is evidence that phthalates may be contributing to low birth weight. And phthalates, there's evidence that phthalates can be harming reproductive health in women as well. When human breast cancer tumors were exposed in the lab to phthalates, cell growth and cell division increased, so the tumors got larger. Those of you with daughters or nieces have probably noticed that girls in North America are starting puberty earlier than in past generations. Some girls are starting to develop breasts at very young ages, as young as 7 or 8 years old. Exposure to phthalates may be contributing to this trend of early puberty. In a recent study, 85 of 90 girls were found to have 3 different phthalates in their blood. Early puberty just by itself is a risk factor for breast cancer. So phthalates and other EDCs that mimic estrogen may be contributing, or there's an increasing body of evidence that they are contributing to the tremendous increase in the incidence of breast cancer in North America. Next slide, slide 24. In addition to harming the reproductive system, phthalates also may be harming the thyroid gland function. In men, a correlation has been found between levels of phthalate metabolites and reduced thyroid hormone levels. Similar correlation has been found in pregnant women. Next slide. Another possible effect of phthalates and other EDCs as well is a contribution to obesity. So we all think that people become obese because they eat too much or don't get enough physical exercise. These are certainly contributing factors. But there's new evidence of another possible contributing factor, exposure during prenatal development or in early infancy to EDCs such as phthalates. The photos in this slide show fat mice whose mothers had been exposed to phthalates at levels similar to human exposure levels, and normal weight mice whose mothers had not been exposed. Both groups of mice were fed the same amount of food, and they had the same amount of physical activity because they were housed in cages of the same area. The only difference between the groups was one group had been exposed prenatally to phthalates, and the other group had not. Phthalate metabolite levels also correlate with the amount of abdominal fat in men and in pre-adolescent girls. In a recent study, the heaviest girls had the highest levels of phthalate metabolites in their urine. And I will revisit this topic in a few minutes. Phthalates also may be damaging the respiratory system. The incidence of asthma has increased in the state of Washington and I believe nationwide. Children in homes with higher levels of phthalates in the air and in the dust have a higher incidence of asthma and also skin allergies. Adult men who've been exposed to phthalates are more likely to have reduced lung capacity. So phthalate chemicals may be harming the respiratory system. Okay, I now want to move on to talking about the perfluorinated compounds, or PFCs. These compounds are constituent of Teflon and of stain-resistant materials. Their ability to repel both water and oil has made them useful in a variety of products such as Gore-Tex hiking clothing and the waxy paper that accompanies pizza when you have pizza delivered to your home. There's many different PFC compounds, but I want to focus on the two that are the most persistent and the most problematic, PFOA and PFOS. PFOA was the one that is used in the manufacture of Teflon products. It has a half-life of 4 years. PFOS was used formerly to make Scotchgard. The 3M company in Minneapolis was the major manufacturer of PFOS. Although the company stopped manufacturing this chemical in 2002, PFOS is still found in the environment, wildlife, and people all over the world. In 2009, the Stockholm Convention designated PFOS as a persistent organic pollutant. It was added to the persistent organic pollutant list. And that's not surprising because its half-life is 8 years. Next slide. The PFCs are found all over the world in air and water and organisms. They've been detected in Puget Sound and many rivers in Washington State. They've been detected in Arctic air, ice, fish, and wildlife. Levels of PFCs in polar bears are 10 times higher now than they were in the 1970s, likely reflecting their increased use and the biomagnification of food chains. Next slide. We're on slide 30. There's not a lot of information yet on how the Teflon chemicals impact fish and wildlife. We do know, though, that when rainbow trout were exposed in the lab to PFOA, cancerous tumors developed. California river otters that died of infectious diseases had higher levels of PFCs in their bodies than did other river otters. This suggests that the PFCs may be harming the immune defense system in river otters and in other mammals. PFOA and PFAS have several reproductive health impacts. Like other endocrine disruptor chemicals, they do cross the placenta during pregnancy. So in a recent study, a correlation was found between newborns with low birth weight and higher PFOA and PFAS levels in their blood. So in other words, the higher the levels of these chemicals in newborn infants, the lower was their birth weight. Similar correlation was found between higher levels of PFOA in moms during pregnancy and lower birth weight of their newborns. PFOA and PFAS impact fertility and body weight as well. In a study of 105 young Danish men, the men with the highest levels of PFOA and PFAS in their blood had the lowest numbers of normal sperm. In a companion study of 1,240 Danish women, the women with the highest blood levels, women with planned pregnancies, the women with the highest blood levels of PFOA and PFAS took the longest to become pregnant. A possible confounding factor in this study, however, is that the husbands and partners of these women may have had low sperm counts as a result of their own exposure to PFOA and PFAS. And when rats and mice were exposed prenatally to PFOA and PFAS, they looked normal when they were born, but they grew up to become obese. So PFOA and PFAS, like phthalates, may be contributing to obesity. Next slide. And we don't know why some endocrine disruptor chemicals may be contributing to obesity, but it's possible that there's some reprogramming of metabolism prenatally. So when the animal is born, it has a lower rate of metabolism throughout its life. Or it's possible that EDCs may be altering the behavior of genes that are involved in determining how many fat cells an individual will have as an adult. So the Endocrine Society, next we're on slide 34, which is a professional organization of physicians who are endocrinologists and biologists doing endocrinology research, looked at all this information about EDCs and recently issued a statement that EDCs are a significant concern to public health and that U.S. policy should follow the precautionary principle. Slide 34 states the full precautionary principle. The gist of it is that when there's evidence that a chemical is causing harm, we should take action now to protect public health and the health of the environment and not wait until harm has occurred. The United States has not followed the precautionary principle. There's a need for a major change in this paradigm in our policy on toxic chemicals. Up until now, our policy has been to wait until the horse has left the barn and then say, whoops, maybe we should take a look at possibly closing the barn door now. That needs to change, and that is fundamentally, in my opinion, what needs to change in order to protect our health and the health of the aquatic environment. That is starting to happen. One thing that can be done is to ban or restrict levels of EDCs and other toxic chemicals. In 2002, Japan banned the use of phthalates in toys and cosmetics. The European Union followed suit in 2005. In 2008, Washington State led the U.S. in restricting levels of phthalates in toys and other children's products such as teething rings, and bibs. The federal government followed with a similar law. Unfortunately, the federal law was less restrictive than the Washington state law, and so it trumped Washington state law. However, Washington state law also requires manufacturers of toys and other children's products to report to the State Department of Ecology when their products contain any of a list of 66 toxic chemicals. The list was just issued. This provision of the law just took effect this week. Bisphenol A and phthalates are on the list. If you are concerned about non-toxic toys for the children in your life, you can go to the website shown in the slide and download the Consumer Guide to Toxic Chemicals in Toys, and you'll get guidance on which toys are safe to purchase. So I see we're running out of time, so I want to just quickly talk about a couple of regulations that have been introduced into Congress. Slide 36, Lisa Jackson, the U.S. EPA administrator, is shown giving a speech in 2009 in which she said that the Toxic Substances Control Act needs to be updated. This law was passed in 1976. It required toxicity testing for new chemicals. Chemicals that were already in existence were exempt from the testing. And the testing required for new chemicals was only one chemical at a time and only for acute effects. So, for example, if a chemical was applied to the skin of a rat and the rat did not develop a rash, then the chemical was proclaimed to be safe. The law does not cover long-term effects of chemicals or the effects of mixtures. So an excellent bill was introduced by Senator Frank Lautenberg into the United States Senate on April 14th. It's called the Safe Chemicals Act. It will update the Toxic Substances Control Act by requiring new health and safety information for all chemicals and by requiring health-based safety standards that would protect vulnerable populations such as children and babies and would take into account the effects of mixtures and cumulative exposures. In June, several members of the U.S. House of Representatives introduced the Safe Cosmetics Act. We're on slide 38. This would require manufacturers to test and disclose all ingredients, including those in fragrances. These two laws, if passed, would go a long way to protecting us and our loved ones and aquatic organisms from the harmful effects of EDCs. So one thing we can all do is contact, for those in the audience who live in the United States, you can contact your two senators and your representative, urge them to co-sponsor these bills if they're not already co-sponsoring them, and urge them to vote for these bills. You can send an email or you can call the Capitol switchboard. So I've shared a lot of alarming information about EDCs. I want to end with a few quick suggestions of individual actions we can take to reduce our exposure and the exposure of our loved ones to these chemicals. First, we can take off our shoes before entering our homes because, and this will help to avoid tracking in dust, which may have phthalates and other EDCs present. We can vacuum our homes more frequently. We need to avoid products that are fragrance-free. Some manufacturers of personal care products, such as Earth Sciences and Ballard Organics, do produce products that do not contain phthalates, and the bottle or jar will say fragrance-free. This slide 39, has a website you can go to find out which products do not contain artificial fragrance. When possible, I recommend reducing your exposure to pesticides by eating organically grown fruits and vegetables. I realize that organically grown produce is more expensive than conventional produce and that it's not accessible everywhere. But if you can access it, if you can buy it, I recommend that you do so. Washington State, and I believe most other states and provinces in Canada, issue fish consumption advisories indicating which species of fish are free of toxic chemicals and which have high levels of toxic chemicals and should be avoided. The good news is that salmon are a healthy fish to eat, perhaps because they don't live as long as other fish and because they move around between freshwater and saltwater during their life cycle. They don't stay in one place for their whole life. Levels of EDCs in the fillets of salmon are not high, so most salmon are safe to eat. Some other suggestions are in the next slide. Because phthalates are found in soft plastic, you do not want to give plastic toys to babies. If you use plastic containers for storing food, choose containers with numbers 4 or 5. Those containers are made with phthalate-free plastics. And you do not want to heat or microwave food in plastics because any phthalates that are present would be released. Likewise, it's okay to use Teflon cookware if the pot or pan is intact, but you want to keep the stove at low or medium heat. So if you heat something in Teflon at very high heat, that enables the PFOA to be released. The next slide, 41, gives you the number of the U.S. Capitol switchboard to call for calling and leaving messages for your legislators. And then as your schedule permits, I encourage each of you to get involved in an environmental nonprofit organization that is addressing EDC's issues and is working on policy changes to reduce our exposure. So the next slide, slide 42, lists several of these organizations, including Alaska Community Action on Toxics. The websites of these organizations provide excellent information about EDCs. And then the final slide, if you want to delve more deeply into the topic of EDCs, I've listed 3 books that I would recommend. So thank you for your attention. I believe Pam Miller has some announcements, and then I'll take questions.
Thank you so much, Fran. This is Diana, for your excellent presentation and for sharing your expertise with us so we can take individual and legislative actions to reduce our exposure to these harmful chemicals.
You're welcome.
Thank you so much. And now I'd like to invite Pam Miller, our Executive Director of Alaska Community Action on Toxics, to speak briefly on how protective legislation in the state of Alaska can protect environmental health. And then I'll open up the lines for some questions. Pam?
Yes, thank you, Diana. And Fran, thank you so much for that very informative presentation. I enjoyed it a lot.
You're welcome.
I just want to mention, Fran, you talked about some federal legislation, and I just wanted to mention a few things that are happening on a state level, because in many respects, states around the country are really leading the way in taking action to limit our exposure to some of these endocrine disrupting chemicals. And I'm very pleased to say that the Alaska State Legislature is no exception, and we are pleased to support legislation sponsored by Senator Bill Wielechowski, Senate Bill 27, and on the House side, a very similar bill, House Bill 63, introduced by Representative Lindsey Holmes. And this is a bill that would phase out the class of endocrine disrupting chemicals known as polybrominated diphenyl ethers that Fran mentioned early on in her presentation. This is a type of flame retardant chemical which has been linked with a number of adverse health effects. They're used in many consumer products such as TV and computer casings, upholstery, textiles, mattresses, and foams. And we find that there are many safe alternatives to these harmful flame retardant chemicals that do not compromise fire safety. So just in brief, some of the health effects that are associated with these chemicals are especially neurodevelopmental effects. And Fran talked about how children are more vulnerable. There's a very important study that was done at the Columbia Center for Children's Environmental Health by Julie Herbstman, who we had on an earlier CHE call, who talked about how children that were exposed in their mother's womb had lasting effects on their learning, their intelligence, and their physical and motor functions well into childhood that could perhaps be permanent. These chemicals are also associated with thyroid disruption. You can find out a lot more information on our website and how to take action in the state legislature, because we would really like to see these bills pass in this upcoming legislative session, which begins in January of 2012, but it's not too early to contact your legislators in support of this legislation. So if you go to our website at akaction.org and the state legislation section, you'll find a lot of information about the bill, how to contact your legislators, and also we're really pleased to enjoy the support of many other groups in this legislation, such as firefighters, tribes, healthcare professionals, and groups that serve people with learning and developmental disabilities, such as the ARC of Anchorage. So please go to our website, get more information. We really would appreciate your support. Samantha English, who in our office is the lead person, if you'd like to contact her for more information. And also we've had a number of CHE Alaska calls about this class of chemicals and about policy actions on this class of chemicals. And again, thank you so much.
Thank you, Pam. We would now like to open the lines for questions and comments, so please just wait a moment while we unmute the lines. If you'd like to ask a question or make a comment, please press *6 on your telephone to unmute your line. And we invite anyone to ask a question of our guest, Dr. Solomon, or of Pam.
Yeah, should be.
If you could state your name, and if you have an affiliation with a group, if you could indicate that as well when you ask a question, that would be great.
This is Jessica Winstaffer with Chickaloon Village Traditional Council, and I wanted to find out if there's a website or another source for more information about personal care products that have been tested and do contain, or also tested and don't contain phthalates and other EDCs. I did check out the attachment on ACAT's website of the PDF that lists 72 products, not too pretty phthalates and beauty products. But I wanted to find out if there's any other website for a more comprehensive list. Thank you.
Okay. Yeah, thank you. Thank you for your good question. Yeah, if you go to the slide 42, in which I listed websites, Safer Chemicals, Healthy Families, I think will provide comprehensive information on personal care products that contain phthalates and that don't contain phthalates. So I would recommend starting there. Additionally, the Washington Toxics Coalition website provides links to documents which will provide that information.
May I add to that?
Yes, who are you?
Hi, I'm sorry, this is Mary Margaret Thomas. I've met Fran before. I'm working with Physicians for Social Responsibility.
Great.
Yeah, there's a website, and I believe the ones that Fran mentioned link to this website too. The Environmental Working Group has a database. It's www.ewg.org/skindeep, SKINDEE. That's a whole database of cosmetic products and sunscreen and everything, and it
Good. Thank you, Mary Margaret. That was an excellent addition.
Are there any other questions? I know there's a lot of background static and noise, but I'm still able to understand, so I think we should continue.
This is Sharon Whitehall with MAP in Homer.
Hi, Sharon.
Hi. I don't have a question. I'm really still just digesting. I just want to thank you for giving us all this information. It gives me lots of directions to go, and I just really appreciate that you're doing this work.
Good. Well, thank you. I was glad to share the information, and glad to hear that it'll be useful for you.
Yeah, absolutely. Thank you.
You're welcome.
Thank you very much, Fran.
It is at the top of the hour, but I think we could just take one more question if if anyone has one out there. Well, if not, I guess we'll end on time then. Thank you so much, everyone, for calling in. Thank you again, Fran, for your really thorough presentation. It did give us all a lot to think about, a lot of directions to take action.
Good.
If you have additional questions or comments, you can feel free to contact Alaska Community Action on Toxics at 907-222-7714. Also, if you have ideas about future topics that you would like for us to explore on this call, please call and give us some ideas. You can also email me at Diana, D-I-A-N-A, at akaction.org.
Yeah. This is Fran. Can I mention one more thing?
Absolutely.
Yeah, if anyone thinks of questions, when you look over the notes, if you think of questions later on, perhaps you could email those to Diana, and she'll email those to me, and I'd be glad to respond.
That's wonderful, because we do often have follow-up questions, so I appreciate that.
Okay,
Great.
good.
And we should be posting this call to our website hopefully within a week, and that way if you'd like to hear it again or share it with your friends or colleagues, you can do so. Again, our website is www.akaction.org. And I want to thank everyone very much again, and stay tuned for our September topic, which is yet to be decided, but we'll promote it the way that we usually do through the listserv. So thanks so much to everyone. Have a wonderful day.
Bye-bye.